We know what composite numbers are. To our lesson on prime factorization. You have a lot of knowledge right now about prime factorization because you know what prime numbers are and you know what composite numbers are. And you also know what factors are. So before we get started, I'm just going to briefly show you how simple this lesson really is. If I have the numbers 3, 3, and 5, I know each of those numbers are prime numbers. If I multiply them, now my numbers aren't just numbers, they're all called factors because they're numbers being multiplied. The answer to 3 times 3 times 5 is 3 times 3 is 9. 9 times 5 is 45. So the answer to 3 times 3 is 5 is 45. So what I just did was I found the prime factors of 45. And that's all prime factorization is. So let's take a look at our formal definition. It's a composite number that can be expressed as a product of prime numbers. So the prime factorization of 45 is 3 times 3 times 5. Another way to think about it, which is probably an easier way, is to think about it like this. It's finding which prime numbers multiply together to make the original number. So you've probably seen a factor tree, and that's how we find prime numbers. So we will start by writing a composite number. Let's start with our composite number of 100. I know 100 is composite because it has more than 2 factors. So I can write any factor pair. I'm going to choose 2 times 50. 2 is the smallest prime number. And since 100 is even, I know that 2 will divide all even numbers. So now that I've broken 100 down into 2 factors, 2 times 50, I identify either one if they are prime and I circle them. So I circle the 2 and now I look at my 50. So I have 50 that needs to be broken down and I can think of any 2 factors I want. So I know 5 times 10 is 50. I take a look at those 2 numbers and I find a composite or a prime. 5 is prime and I circle it. 10 is still composite, so it can still be broken down. So the 2 factors that make up 10 are 2 times 5, and I identify them as prime so I can circle them. So my final answer, if I look at all the prime numbers I have circled, I'm going to order them from least to greatest. 2 times 2 times 5 times 5. If I check to make sure that's the right answer, I will see that it is. 2 times 2 is 4, 4 times 5 is 20, and 20 times 5 is 100. All right, so that's how you do a factor tree. We're going to practice again with the number 100, and you're going to see we could start with any 2 factor pairs. So another pair of factors that go into 100 are 4 times 25. All right, they are both composite because they have more than 2 factors, so I keep breaking down every factor until it's broken down into the prime factors. So 2 times 2 is 4. Those are both prime. I'm going to circle them. How do I break up 25? 5 times 5 is 25. They're both prime. I circle them. All right, I have all of my numbers circled. They're all prime. I'm going to write them in order from least to greatest. 2 times 2 times 5 times 5. Again, I check back to make sure when I actually multiply those numbers, I get 100. And I do. 2 times 2 is 4. 5 times 5 is 25. And 4 times 25 is 100. Now, what do I notice about my final answer in both boxes? Well, the answers are the same. They are the same. That just means that I can start with any 2 factors, and that composite number will always boil down to the same prime numbers. Then my final question, can you write the prime factorization of 100 in exponent form? To do that, you would have 2 to the second power. That means 2 times 2 is 4 times 5 to the second power. That means 5 times 2, or 5 times 5 is 25. If you are trying to remember what exponent means, go ahead and turn your page, and here's a little chart on what exponent means. Have a great night.